Hello everyone, welcome to the NDIS webinar. I'm Samuel Chung from NDIS Technology. The talk of my presentation today is to provide a comprehensive guide to the NDIS core processor IP lineup. First, let's talk about RISC-V International and NDIS Technology. RISC-V International is a foundation formed in 2015 with the goal of promoting the RISC-V ISA worldwide, which is based on the principle of open, compact, and extensible standard. Through its efforts, it has accumulated over 3,600 members in the year of 2023, and an extensible instruction has grown from the IMAC-FD extension to newly rectified 16 plus new extension in the 2023 period. Its vision is to enable all computing devices to run on the RISC-V ISA. NDIS is a pure-play CPU vendor formed in 2005. And in the early days, we have our own ISA, the V1 to the V3 generation. But in the recent years, we have focused our efforts on developing RISC-V-based V5 instruction set, plus the NDIS extension. We are very active in the RISC-V community. We are a founding and premier member at RISC-V International. With our continuous efforts, we have seen really good traction and adoption of our V5 and this RISC-V cores with our customers, with their designs targeting MCU all the way to data centers. Their SoC are targeting from edge to the cloud. This includes ADAS, AIoT, blockchain, FPGA, MCU, multimedia, security, and wireless. In recent years, we have a lot of design wins for data center and server AI accelerators. For the SSD enterprise and consumer-grade controllers, we also have a lot of licenses. And we have also customers taking our core to design for 5G macro and small cells. Our customers have taken our NDIS cores and tape out at 40 nanometer process and all the way down to 5 nanometer process. And with AI being a very hot trend nowadays, many customers are evaluating or licensing our cores for AI application. In this table, you can find a comprehensive portfolio summary for NDIS core. Vertically, you can find different series. At the bottom, you can find the compact series, which feature very compact and highly efficient cores. The 25 series are 5-stage fast and compact processors. The 27 series added the MEMBoost technology to the 25 series, and this enhances the memory performance of the processors. The 45 series boasts 8-stage and superscalar processors. The AX60 series is our flagship product line with 13-stage out-of-order processor that support Linux multi-core. And with the different microarchitecture designs and different feature sets, our cores can cover different application segments. These include embedded control. And with our DSP and vector engine technology, we have cores that can cover compute acceleration. And with our MNU and multi-core processor, we can support Linux or Android application processor. And with our functional safety development process, as well as functional safety enabled cores, we have the FUSA series or the safety enhanced processor series. Also, we are planning to release new cores this year in 2024. These are the D25FSE, D45SE, and AX66. And also, we are actively planning for future cores. These are D23SE and AX66XSE. Let's first take a look at the NDIS core AX65 out-of-order application processor. It is a 13-stage 4-way decode 64-bit out-of-order processor that supports the RVA22 profile. In a cluster, it can support from 1 to up to 8 cores, and it has 8 execution pipes or engine that support 4 ALUs, 2 load and store units, and 2 floating point units. It has advanced branch predictor technology with the 2-level branch target buffer and the TACH-L technology. For the caches, it can support configurable size of per core private level 1 cache and also a per cluster shared level 2 cache up to 8 MB. For the bus interface, it supports 256-bit wide AXI4 for the memory map I/O, and I/O coherent port. Performance-wise, it can achieve 7 nanometer on a 7 nanometer process, 2.4 gigahertz, and with spec in 2006, 8.25 per gigahertz, and spec FP 2006, 10.2 per gigahertz. I believe for the two-level cache microprocessor, this class of processor, it has the best spec 2K6 performance in that class. And already we are planning to release other derivatives of the x65. For this year, we are planning to release the x66 processor that support multi-core coherency and multi-cluster design, and also technology like hypervisor and vector crypto. And beyond x66, we are planning to develop x67 that support the latest RVA24 profile, and additionally increasing the overall performance of the processor. And based on the market and customer feedback, we can also develop a power and area optimized version. We call it AX63. So this family of processors are targeting to support Android as an application processor solution. Next, let's look at the ND-Core 45 series lineup. This is a family of processors with different cores. The baseline is the N45, which is a 32-bit processor, and its 64-bit version is the NX45. They both support the RV GCB extension, where G is short for IMAFD extension. They are suitable for high-performance embedded system designs. And then D45 supports the P extension, which is in draft stage at RISC-V International. That supports the DSP and SIMD instructions. This is very useful for multimedia type of workload for video, image, and audio codec processing. And then we have the A45 and AX45, which supports MMU to run a Linux operating system. And then we have A45MP and AX45MP, which support multiprocessing up to 8 cores in a cluster, and can optionally support level 2 cache in the cluster. So let's look at the microarchitecture diagram of the 45 series. It's 8-stage in order dual issue processor. And as mentioned, there are different variants depending on the extension they support. But all cores in the series supports the ND's extension, which provide performance enhancement and code size reduction to the cores. They support configurable size level 1 IND cache, and optional parity and ECC protection, error protection, and also support configurable size IND local memory, and also with optional ECC error protection. It can issue dual issue most of instruction pairs, and it supports low power dynamic branch prediction and also unaligned data accesses. And you can configure either a 2-cycle fast multiplier, or you can opt with a smaller size but slower multiplier to make that trade-off. This is an architecture diagram of the A45MP and X45MP. It can support from 1 to 8 cores per cluster to run SMP Linux. The bus interface, it has AXI 128, 256 or 512 master ports, an IO coherent slave port, or an optional shared peripheral port. The AXI bus master interface can be configured to run at N-to-1 synchronous core to bus clock ratio. It supports the standard PLIC platform level interrupt controller to handle interrupt. It also supports vector interrupt for fast interrupt response and priority based interrupt. It supports debug and the instruction trace. The coherency manager supports the messy coherence protocol and also IO coherence for cacherless masters. It can have an optional level 2 cache controller to support level 2 cache size ranging from 128 kilobyte up to 2 megabytes. Next, let's look at the 25 and 27 series processor lineup. They support RV32 32-bit processor and also RV64 64-bit processor. Like the 45 series, it's a family with different cores. The baseline is the N25F, which is a fast and compact processor that can optionally support 14-point units. And it has a version that supports DSP, D25F. And the 64-bit version is the NX25F. And if we add MNU to the baseline, the A25 and AX25, they can support the Linux operating system. And then the A25MP and the AX25MP, they can support multiprocessor with optional level 2 cache and I/O coherency. It can be configured from 1, 2, or 4 cores. The A27 and the AX27 and the version that support L2, they added the MemBoost technology to increase the overall memory performance. It can provide over 2x the memory bandwidth and also about half the latency compared to the A25 processors. And all the cores in this family, they share some similar features like configurable local memory and caches, configurable branch prediction, and vector interrupt controller. They are all 5-stage processor, and on the 28 nanometer process can achieve around 1.1 gigahertz. Here we are looking at a microarchitecture diagram of N25F and D25F. They support the ND-Star v5 architecture, supporting RV32 and RV64 IMACNB extension, plus the NDIS extension. The N25F can optionally support single precision or double precision floating point, and the D25F can optionally support DSP/SIMD-P extension. They can configure the multiplier to either a fast multiplier or a slower but smaller multiplier. It can optionally support different branch prediction with static or dynamic branch prediction. The bus interface includes two AXI64 or two 32 or 64 HP bus interface, and an optional AHB slave port to access the ILM or data local memory. For power management, it supports the wait for interrupt instruction so that the processor will enter idle mode until a new interrupt comes in, and then you will wake up to process that interrupt. It supports a power break technology, which can digitally stall the pipeline to reduce the processor performance, but can achieve power saving with this technique. The core can support configurable size IND local memory with unaligned load and store accesses and optional parity or ECC error protection. It can support configurable size IND cache and also has the option for parity or ECC error protection. It can support physical memory physical memory protection PMP with up to 16 entries to control the accessibility of the memory regions. It can support JTAG debug module with up to 8 triggers of breakpoints and watch points, and 4-wire JTAG or NDIS 2-wire serial debug. For interrupt control PLIC, it can support up to over 1,000 interrupt sources with 255 priorities and 16 targets. The 45, 25, and 27 series processor can target a variety of different applications. These range from AI and deep learning, AR, VR, or mixed realities, 5G, networking, storage, video surveillance, automotive ADAS, vehicle-to-everything connectivities, in-vehicle infotainment, and many more other applications. Let's switch gear to talk about how NDIS leverage the RISC-V architecture to provide solutions for AI. RISC-V provides a powerful extension, the vector extension RVV, that can support many basic high data rate AI computations. RISC-V also allows extensibility to support address the ever-evolving requirements of AI workloads and algorithms. These requirements include having efficient control or data transfer between the processor and the external accelerators. The technology to harden the design to support key transformer operations found in many of the large language models, and also have a full set of support for the BFlow 16 data type that's commonly found for AI algorithm and workload. And vector processing is not only beneficial for AI, but also beneficial for networking, multimedia, and computation kernel computations. For other endpoints with low data rates, applications, we believe that RISC-V, SIMD, and DSP with the TP extension should be an effective solution to address these kind of devices. Next, let's look at two generations of the NDIS Core's vector processor. The first generation is the NX27V that can support up to 512-bit VPU or vector processor units. It is the first RISC-V commercial vector core that supports the RISC-V RVV standard v1.0. It supports various RVV data formats. For the standard ones, for the int8 to int64 and FP16 to FP64. And we also have extended support for BFlow 16 and int4, which are popular data formats for AI workloads. And the NX27V has a very efficient scalar unit and also a very powerful vector unit or VPU. Every RVV instruction, it starts execution after being retired in the vector unit and passed into the vector unit. And inside the vector unit, there are multiple functional units which are parallel and fully pipelined. And the data can be forwarded or chained between the different vector functional units for efficient processing. The VLAN and the SIMD width can be 128 to 56 or 512 bits. And there are two different independent ways which the external data can be fed into the VPU. One way is through the RVV load and store instruction to load the data from the data cache or system bus into the VPU. Another way is through the NDIS custom extension by instantiating an NDIS streaming port ASP and then using the ACE load and store instruction to load the data externally and into the VPU, thereby lifting the overall VPU performance. The second generation NDIS vector processor is the X45MPV, which extends the VPU support up to 1024 bits. And the scalar processor design is similar to the other 45 series core, and it supports the RV64 GCB PMV extension and also the NDIS extension. It's an in-order dual-issue 8-stage pipeline design. In a cluster, it can support up to 8 cores per cluster with shared L2 cache, and each core has a scalar unit and one VPU unit. It shares the same cache configuration as x65. It can support SV39 or SV48 MNU. On the bus interface, it can support 128 up to 512-bit AXI memory interface, memory mapped I/O interface, and I/O coherent port interface. It supports the RISC-V RVV spec 1.0. And on the vector processing unit, it has multiple independent vector functional units, and it can dual dispatch a vector instructions pair. It can configure 128 up to 1024 VLAN and DLAN widths, and the data format, it can support int8 to int64, FP16 to FP64, as well as BFlow 16. Through the ACE technology, it can support custom vector instructions, which I will describe in more details. On the performance side, it can support 6.04 core mark per megahertz, 3.39 DMIPS per megahertz, and 4.07 spec in 2006. Many of the NDIS cores support the ACE NDIS custom extension. Additionally, X45 MPV, the vector processor, can support RVV style custom instruction. We call that the ACE RVV, and the design will sit inside the vector engine just like any other vector functional unit pipeline. It can perform 3 read, 1 write to the vector register file or the integer or floating point register file. We provide very powerful tool, the compiler, that can generate the RVV extended RTL, the extended instruction set simulator, and the extended tool chain components. It can also generate the LLVM compiler for auto vectorization, instruction scheduling, and register allocation to efficiently speed up the computation. So we have done some benchmarking looking at some of the different algorithms, the speed up of ACE RVV over pure RVV. And for different algorithms for exponential, sine, cosine, matrix multiplication, convolution, and complex multiplication, the speed up ranges from 1.7x to 18x, showing very good performance enhancement with ACE RVV over pure RVV, which bring a lot of benefit for AI type of workload. Next, let's look at the compact RISC-V cores, D23 and N225. They are 32-bit 3-stage pipeline core with some dual-issue capability, and they support many of the latest RISC-V extensions. D23 supports the IMACB, ZCE, F, D, P, K, and CMO extension, whereas N225 is a more simplified design and does not support 14-point DSP and caches. And they support many of the security functions and all the ND-Star V5 ISI extensions. And D23 has a plan to support ACE in the futures. They support 4-wire JTAG and 2-wire serial debug and also instruction trace, and also can support integrated machine timer and debug module, plus many configurable options. And overall speaking, they provide better performance and smaller code size than ARM Cortex-M33. For example, they can achieve 10% higher performance than Cortex-M33 in core mark per megahertz, and 10% less code size than Cortex-M33 across many benchmarks. Because of their high configurability, compact design, low power, high security, they can target a wide variety of IoT and embedded applications, such as smart home, wearable, factory automation, sensor fusion, motor control, and touch and display driver. In recent years, NDIS has put out efforts into developing and promoting functional safety capable cores for the automotive segment. On this chart, you can find a comprehensive list of the cores that we are targeting this application. They are derived from our baseline cores, applied with the functional safety development process, and adding the necessary safety capabilities into the design. And you can find the IP availability and certification readiness dates on this graph. And they can target a wide range of automotive designs, from mainstream processing to mission critical to where low power and security is important, as well as in the future targeting high performance ADAS type of applications. And through our efforts, our first N25F SE has been designing over 10 different customer projects across a variety of different automotive applications. And some of our customers are already leveraging our safety package to pass the SOC level safety certification. And we are working actively with a lot of software partners to provide safety grade tool chains, C-code verification software, middleware, and AutoSAR middleware to enable a more complete safety automotive solution for our customers. And that kind of summarize all the cores available from NDIS for licensing today. And whenever a customer licenses our core, we also provide a reference design platform, the AE350, to help our customer with quicker time to market and reduce their effort by providing integrated core with bus matrix with different APB peripherals and click and debug module. So it's a great platform to speed up the SoC development. So we have looked at all the cores from Enders, and this is a different way of presenting them. Basically, we have different series, the 25 series, the 27 series, 45 series, and the 60 series with different microarchitecture and different performance points. And they support different features such as FPU, DSP, multiprocessor, and Linux capability. And 27 series with the MemBoost technology to enhance the memory performance. 45 series with the superscalar dual issue microarchitecture. And we also have the powerful vector processor with NX27V and X45 MPV. And the 60 series is our highest end performance processor, 13-stage out-of-order pipeline design that can run over 2.4 GHz in 7nm design to support Android and application processor. So overall, very complete and comprehensive offering from Enders. In summary, RISC-V and Enders can help you develop your SoCs. RISC-V has become a leading choice of processor for SoC and computing platform. Due to its openness and technical merits, it's drawing a large number of companies to join its fast-growing ecosystem. And Enders brings RISC-V benefits to your SoC design for different applications from edge to cloud by leveraging the RISC-V ISA, Enders unique extension, and our ecosystem partners. So if you are planning your next SoC development, please consider adopting RISC-V and come to talk to us. We are here to help you. Thank you for your time and attention today.